Hi everyone. In this session we are going to discuss about PySpark aggregations. We will see what all aggregation mechanisms are available in PySpark, and we'll try to run some PySpark code here. So let's get started. So in order to proceed, what we will do, we will try to read some data from the data source. So I already have detailed data here, so in this path location. So we'll try to read this data, right? And then we will apply some aggregation functions. So let's start. Dot format. Okay. Options. Okay. So we have already copied the path. So this is the path, and file name is online retail dataset. So let's put it again. Yeah. So we will use here a coalesce function so as to limit the number of partitions which will try to read the dataset. So let's say 5. Okay. And then we will create a temporary view. Let's say name would be df table. Okay. So we can try to print some record and see whether it is able to get the data or not, so that we are able to read the retail dataset CSV file. Okay. Now switch to aggregate functions. So the simplest one which I can think of is df dot count. It will give you the number of counts. Basically df dot count is a action as opposed to a transformation, so that's why it return the results immediately. Okay. So now we can see some variations of count. So we can also pass column name inside the count. Suppose we have a select df dot select, and then inside that we can put count of let's say stock code, right? Okay, so count is stock code, and then we can say show let me run it. So it says count is not defined, so we have to import this count function. Okay. PySpark part SQL dot functions dot count, right? Now we can run the statement, and indeed it got executed, and we can see actually the numbers are exactly same here, but this is a transformation here actually. So when we are performing a count star, Spark will count null values and including rows containing all the nulls. But however, when counting an individual column, Spark will not count the null values. So how it is in with respect to the count function, right? So since we have created a view also, so we can execute a SQL statement here. Okay. On this star. Okay. So since we have created the view, we are able to execute the SQL statement also. I think this will get executed. Yeah, so it is printing the same values. This function will count the distinct values. So suppose same thing, we can copy it from here, and instead of count we will give the count distinct. Okay, and then we will try to print the values. So again, I think we might get the same error. Count distinct is not defined. So yes, we will have to import it, and then we'll have to run it. Okay, yes, so now we can see that this is giving us the distinct stock code in the dataset, which is 4070. Okay, similar, we can execute the SQL statement also. Select, and we can run this SQL statement. So we can see now the numbers are same. So both the SQL approach and the PySpark approach, both are giving us the same number for the query, right? Now we will see other function. There is something called approx count distinct. So suppose in the same statement, okay, okay, so instead of count distinct, we can give approx count distinct, right? Same function, and it accepts one more parameter. So here I am saying which is basically relative standard deviation. So here we are saying that value is 0.1, which means it has a error tolerance of 10%, and this function is relatively faster as compared to other count distinct functions or count function. uh, uh, yeah, so let's execute this. I think we will have to import this also. Yeah, definitely. So we'll copy the what statement and put it here. Okay. So now you see 3364. So actual distinct count of stock code is 4070, but with this approx count distinct function, it is giving us this value which has a error tolerance of 10%, but it is relatively faster in giving us the result on which we can work basically. So now we'll go to next function. So we have something called first and last. So in the same data set, df dot select first, I would say stock code, and last stock code, and then show the value. So we'll have to import it as it clearly stating the error is there. Spark SQL dot functions. Yes. So this is very simple function. It gives the first and the last stock value from the data frame, right? Now we will see mean and max aggregation function. As the name suggested, it will give us the mean and max values. So we already let's try to print the data frame here. Data df dot show 10 records. Yeah, so we can see here there is a column quantity, right? With respect to stock code, there is a different quantity. Okay, so we might want to see across the data frame what was the minimum quantity and what was the maximum quantity, right? So that we can see here. Okay, okay, so the minimum is minus 80995 and the maximum is this, right? So this gives you the minimum and the maximum. Okay, so in this same thing we can modify this query and add some filter. Suppose we want to say select mean and max, and then mean and max, and then filter it filter for column invoice number equal to this, right? I think we'll have to import the function here. Okay, so now we will add a show function in the last. Okay, so this has some error, so let's see what is the problem. All right, so this has some error. So can you identify the error here? So let me fix this for you. So here in the error it is saying invoice number cannot be resolved. That means it is not able to find the invoice number data. So what we can do here is, because we have already selected mean and max and that is only present in the data, and then in the chain we are giving filter, so obviously it won't be there, the invoice number, so we have to put it front, and then we have to do the select mean and max of the quantity, then we will get the final result. So let's run this. Okay, so there is some syntax mismatch. Okay, so I forgot to give the number here. Yes, let's give this invoice number. Yeah, so what I am saying, for this particular invoice number, what is the minimum quantity and what is the maximum quantity? So minimum is 2 and maximum is 8. So now let's little tweak this statement into another meaningful statement. Let's copy this again below. Okay, and now we will remove this filter part from here. So what we want to do, we want to do only the max part here for a particular invoice number, and the minimum will be across all the invoice numbers. So what we can do here, so minimum we will leave it as it is and it will span across all the rows. But in the max function, what we can do, we can add a when function here, when, and then we can put the column name, invoice number. Okay, now we are saying find the max value of the quantity where the invoice number is this, right? So this is some extra thing. I think some syntax error is there. 1 second. Some format error, right? So I think this is closing where, nowhere. Then we need to add this. Now it is closing there. Then one more for this. Okay, now we will get error when is not defined. So I'll copy the same thing, and actually this time I will give a star for safer side, and then we will run it. Okay, so now we are getting the same 8 value here, right? Because in the above query, what we have done, we have filtered for this particular invoice number and we have applied mean and max for then afterwards. So that's why the data set available after the filter was only for this particular invoice number, and then it was doing the mean and max. But here the mean is across all the data sort, but max is only for this particular invoice number. So we can again do alias and change the column name here. So let's add alias. Okay. And run it. Yeah, so now the column name is changed and it looks more neat and clean now.